Welcome to the Explainer, everyone. Okay, let's just dive right in. We're going to unpack one of the absolute most foundational and, frankly, most powerful tools in modern computing. Think about the sheer scale of the modern web for a second. Have you ever wondered how the massive, sprawling back end of the internet actually gets managed day to day? Or how engineers interact with server racks that are miles or even oceans away? Well, this is your answer. This tool is the invisible workhorse of the digital age. Today, we're demystifying SSH. Seriously, how do you control a computer in Tokyo from your desk in Dallas? Imagine the absolute geographical and logistical nightmare of needing to manage servers in New York, London, or Tokyo on a daily basis. I mean, you obviously can't just hop on a plane every single time a server needs a quick reboot, right? Or when a configuration file requires a routine update. The distance is a massive barrier. You need a reliable, rock-solid way to project your presence securely across the globe, interacting with distant hardware without ever leaving your comfortable office chair.
So, let's kick things off with Section 1, the ultimate remote control. We're going to grasp the core concept of SSH. To solve this exact problem of physical distance, we turn to a tool that essentially acts as the magic wand of the Linux in cloud computing worlds. It's the bridge between your local keyboard and a machine that could literally be thousands of miles away. So let's define our core term here, SSH. It stands for Secure Shell. It's a standard protocol used to securely connect to another computer over a network. Now, the absolute key word in that definition is securely. See, before SSH came along, people relied on older protocols that, get this, unfortunately sent information across the network in completely plain text, no encryption at all. SSH changed the game entirely by encrypting the connection from end to end. This means you can safely reach out across a network, even traversing the wild, unpredictable public internet, and take the reins of another machine without any fear of someone listening in or intercepting your data.
So, what does this protocol actually let you do once you're connected? Honestly, it grants you incredible superpowers over the digital realm. It empowers you to log into remote computers, execute commands remotely, seamlessly transfer files back and forth, and completely manage backend servers from top to bottom. It effectively gives you direct, unhindered access to another computer's command line. It feels exactly as if your personal monitor and keyboard were plugged directly into the motherboard of that distant machine. You type a command locally, you hit enter, and the remote server executes it in real time.
And this tool is absolutely everywhere. It's the very first utility you're going to reach for, regardless of the scale of the hardware you're working with. You'll use it when you're tinkering with a tiny credit card-sized Raspberry Pi sitting in your home closet, managing a standard Ubuntu server for a mid-sized business, or provisioning heavy-duty, massive AWS EC2 instances in the enterprise cloud. It crosses all boundaries. It truly is the universal language of remote system administration.
Moving on to Section 2, Anatomy of a Command, Deconstructing the Spell.
Now that we know what this incredible tool accomplishes, let's break down the actual incantation you type into your terminal. I promise you, it's not intimidating once you see the moving parts. Take a standard command like SSH Ubuntu at 192.168.1.50. By pulling this apart, we can see it's elegantly simple. It basically consists of just 3 core pieces. First, the word SSH calls the tool, waking up the client on your local machine. Second, the word Ubuntu, placed right before the @ symbol, declares who you are, specifically the user account you want to log into on the other side. And finally, the IP address 192.168.1.50 points exactly to where you want to go, identifying the destination computer on the network. Tool, user, destination. That's really all there is to it.
But I do have to offer a bit of a dire warning from veteran engineers to newcomers. Treat your access carefully. If the connection succeeds, you immediately receive a blinking command prompt on that remote machine. Once you hit enter and that connection is established, you have total unfiltered access to that remote machine's command line, limited only by the specific permissions of the user you logged in as. It's a profound power that absolutely demands respect. One wrong, hastily typed command could literally wipe a vital production-level system. So you must always double-check exactly which machine you're currently controlling before you press enter.
All right, Section 3, Passwords versus Keys, the lock and key of authentication.
Okay, so we've seen how to initiate the connection and format the command, but now we really need to talk seriously about security. How do we prove who we are to that remote server? How does the server know you aren't some malicious actor trying to gain unauthorized access? Well, while you can technically use old-fashioned typed passwords to log in, that method is incredibly vulnerable to modern cyber threats. Imagine the terror of brute force attacks on public networks, where automated scripts hurl millions of password guesses at your server every single hour. It's wild. Because of this terrifying reality, modern and secure systems rely heavily on a much more robust method, SSH keys.
So what exactly is an SSH key? In short, it's a cryptographic credential used to authenticate securely without ever needing a typed password. An SSH key is this beautiful, elegant, mathematical solution that completely eliminates the need for human-memorized passwords, while vastly increasing the security perimeter of your server. It relies on complex cryptography that computers can verify instantly, but hackers cannot easily fake or guess no matter how much computing power they throw at it. No way.
Think of the public key and private key dynamic as a very specific lock and key. It works using a mathematically linked pair. You have a public key and a private key. Think of the public key as the specialized lock that you intentionally place on the server. You can hand out copies of this public lock to anyone, or place it on 100 different servers without worrying, but you carefully, intensely guard the private key. That private key is your actual, undeniable credential, and it stays with you, securely locked away on your local machine's hard drive. When you try to connect, the server simply checks if your hidden private key fits its public lock.
Let's look at a concrete practical application using Amazon Web Services. When you're connecting to an Amazon EC2 instance, the command requires a slight but absolutely vital modification. It requires using the -i option to explicitly specify the key file. You actually have to tell the SSH command exactly where your private key is located on your local hard drive. Think of AWS like a strict bouncer at an exclusive club. If you don't use that -i option and point it directly to the correct authorized private key, AWS is going to coldly reject your connection every single time. The server simply won't let you in without seeing the VIP pass.
Which brings us to Section 4, Troubleshooting Common Problems, the Survival Guide.
Now, in the real world of systems administration, things don't always go smoothly on the very first try. You will hit errors. It's just a fact of life. So let's anticipate some roadblocks and figure out how to fix them quickly. There are 3 big errors you likely encounter. First, if you get a connection refused error, it usually means the SSH service might not be actively running on the destination server, or the server is simply offline. Second, if you see permission denied, you need to check your credentials immediately. It means your username is completely wrong or your SSH key isn't matching up. And third, if you get a timeout where the terminal just hangs and does absolutely nothing for a minute, you are almost certainly being blocked by a rigid firewall or a strict network security group standing between your computer and the server. Speaking of permission denied, a very frequent trap that causes that exact denial error is simply using the wrong default username for the specific operating system you're trying to access. Consider this a bit of an insider secret. Operating systems are incredibly picky about this. For example, Ubuntu instances almost always expect the username Ubuntu. Simple enough, right? But if you spin up an Amazon Linux machine instead, it explicitly expects the username EC2-user. If you mix those up, even with the perfect SSH key, the server will slam the door in your face.
Finally, Section 5, the big idea, mastering the remote control.
Let's zoom back out for a second and look at why grasping this tool is so absolutely pivotal for your overall tech journey. SSH is the universal remote control of the Linux world. Whether you're casually managing a local hobby project on a Sunday afternoon, or you're a lead DevOps engineer managing enterprise cloud infrastructure across thousands of distributed nodes, SSH is the universal tool you'll constantly rely on. It is the invisible, secure thread tying modern cloud architecture together, acting as the foundation for how we build, maintain, and scale the digital world.
Learn SSH once and you'll use it for years. You know, the most empowering takeaway from all of this is that the effort you put into understanding SSH today is a permanent, lifelong investment. It isn't some trendy, flash-in-the-pan JavaScript framework that's going to be obsolete in 6 months. It's a fundamental, deeply rooted networking protocol. Master it now, and it will literally pay dividends for the rest of your technical career. So I leave you with this. Next time you sit down at your terminal, what distant machine will you reach out and command today?